All right, everybody, we're going to go ahead and do a short little video talking about functions, just kind of as an introduction, because we're kind of short on time today because we're taking our test and we have a shortened block due to our pause for our cause. So we're going to talk about functions. So here we have a little thing that says functions rule, and we're going to be on top of page 2. All right, so on page 2, there's a little bit of a blurb there. It doesn't say functions rule, but it says function rules. So we're going to go ahead and talk about the rules for functions real quick. So let's read that little blurb at the top. It says, a function may be represented using a rule that relates one variable to another. The input variable x is the independent variable. The output variable y is the dependent variable because its value depends upon or is a function of x or the input value. Function rules typically give the dependent variable in terms of the independent variable. So for instance, in this equation, y equals x plus 3, you know that y is dependent on the value of x, right? So the output of something depends on the input, right? That kind of just generally makes sense. So we want to make sure when it says y as a function of x, that basically means y depends on x, okay? So you're going to hear that a lot, y as a function of x, and that's kind of what that means. So again, x is independent, it's happening regardless. You'll typically see x being things like time, right? 3 hours, well, that's happening regardless. The cost might be the y, the dependent variable. The cost depends on the the independent variable, or in that case, maybe time. Okay, so we're going to do a word problem example in just a moment. But again, y depends on x. All right, so we're actually going to skip around a little bit. We're going to jump all the way to page 3, actually, just page 3, so the next page. And we're going to look at number 6, so the second one on the page. All right, so one thing that you're going to be looking for, and I've already been highlighting it a little bit, is the phrase as a function of. This is going to help you to, figure out which of your variables are the independent and dependent. It's kind of like, almost like a little cheat code, okay? If you see that phrase, while it might be a little confusing at first, I'm going to help you to decode it. So, so again, it's going to say things like write a rule for blank as a function of blank. And since it's always y as a function of x, whatever the phrase you see before as a function of is going to be your y, and then whatever you see after as a function of is going to be your x, or your independent variable. All right, so let's give it a shot. It says you join a kickboxing class at a local gym. The cost is $5 per class plus $25 for the initial membership fee. Write a rule for the total cost of the class in dollars as a function of the number of classes you attend. And then it asks, how much will it cost if you go to 8 classes? So first thing I'm going to do is I saw that phrase as a function of. So I'm going to go ahead and highlight that as a function of. And the most important part is that the phrase you see before is your y. So write a rule for the total cost of the class. That's going to be our y. So, here, let me do the x as well. As a function of the number of classes you attend. So that's going to be our x. So let's go ahead and write that out. We'll do, yellow's not really going to work. Oh no, green we did. So green is total cost. So that's our y. Total cost. And then, and that means then, and we use blue kind of, for the number of classes. So number of classes. Oh man, I keep hitting a button. Classes. All right, sure. So we know that x is the number of classes, that's our input, and the y, the total cost, that is your y, or your output. So we can go ahead and try and come up with our equation now. So the cost is $5 per class plus $25 for the initial membership fee. All right, well that's $25 happening once. We're paying $5 per class. Well, number of classes was x, so 5x plus 25, and that's going to equal our total cost. Okay, this is our equation here. So again, the total cost is going to be $25 plus $5 per class. So x is the input, number of classes, y is the output, total cost. Now I ask the question, how much will it cost if you go to 8 classes? Well, x was our classes, so we're going to plug in 8 for x. So y is equal to 5 times 8 plus 25. So 8 times 5 is 40 plus 25 means that y is going to equal 65, and y was total cost, so that's dollars. So we're going to say $65 for the 8 classes. All right, let's keep it moving. This is now on the bottom of page 5, so we can fast forward a little bit. Let's see, there it is. So if you scroll to page 5, there's a little bit of a graph made for you. It gives you some input. Yeah, okay, wait, sorry. So this is on the very, very bottom of page 5. If you scroll to it, there is a data set there, so not the actual graph on page 5. And I think I'm just looking on my other screen at where the packet is. I believe, oh yeah, no, okay. So you're gonna go ahead and use the graph that's on page 5 above this problem, but again, the function y equals 1/2 x is below it at the very, very bottom. So anyway, it says it has a domain of 0, 2, 4, 6, 8, okay? So that means our x value is only gonna be 0, 2, 4, 6, and 8. We do not care about any other x values, right? We could not plug in 1 because it's not given in the domain. So this is what we call a restricted domain. All right, so we're gonna go ahead and plug these values in. So if I plug in 0 for for x here, 1/2 of 0 is still 0. If I plug in 2, I'll actually visually show that one. 1/2 times 2. Well, if I multiply these together, when we plugged in 2 for x, this ends up just equaling 1. And it's just saying a half of whatever x is. So a half of whatever 4 is, so we plugged in and we get 2. Half of 6 would be 3, half of 8 would be 4. All right, so this gives you a bunch of ordered pairs that we can now graph. All right, we have 0, 0, that's pretty simple. Let's go ahead and plot that. 0, 0. We also have 2, 1, so 1, 2 on the x-axis, up 1 on the y. We'll go 4, 2, right here, 6, 3, and lastly we have 8, 4. And what you should notice is that these come out in a line, right? They all end up in a pattern. And when we graph linear functions, which is what this chapter is all going to be about, we are going to end up getting things in a line. So if you graph these and you get something like maybe one standing out here and it's not in an exact line, you should know, okay, I must have done something wrong. Specifically, let me check this point. Maybe I either plugged it in wrong or maybe I graphed it wrong. So you should get a line. Now the question is, do we connect this with an arrow, a line, or something like that? And the answer is no. And that is all to do with the fact that it gave us a specific or restricted domain. It gave us 5 specific numbers. And when it gives you only specific numbers as the domain, well, then you should only get 5 points. Or in this case, 5 points. Depends on what the domain is. All right. So you should not connect if the domain is a set of numbers. Okay. If we are asked the range, we'll write it right here, the range, then you should go ahead and just write down, it should look exactly like the domain did. So in this case, it was 5 numbers and those were your x. Well, our range should be those 5 numbers we got for the y, or our output. 0, 1, 2, 3, and 4. All right, my squiggly brackets are struggling a little bit. So there you go. Take note, we would normally have labels here on the x-axis and y-axis, but we don't here because it's not a word problem. All right. I want you to go ahead and do number 6. I'm going to go ahead and just do it without talking, so that way you can kind of once you pause the video, you can go ahead and see what the result is. So yeah, it's going to look something like this. So actually, I'm going to pause the video so I could just fast forward to the answer. All right, so here's the result. This is what you should have. Ooh, actually, I messed up. This last one should be up a little bit higher. It should be here. All right, cool. So again, once we notice, we should have them in a straight line. I have a little pun here. So this is this is ordered pairs. Notice they're pairs and they're in order. But yeah, when you graph this, or when you make your table of inputs and outputs, note that you do get ordered pairs, right? These end up coming out as x and y values. And remember that an ordered pair is always an x value and then a y value. Yeah, so let me talk to you about the last thing, right? This is the last piece. And this is being able to tell, and this is on page 7, being able to tell whether a function, or a graph specifically, is a function or not, okay? And what we use is something called the vertical line test, all right? So what you're supposed to do when you do the vertical line test is move a vertical line. You can use your pencil for this, or just, a visual line. And you're gonna drag it from left to right across your graph. And the test is whether or not that vertical line touches your function at the same, or multiple times at any one point. So in this case, it's only touching the line right here. If I were to move it forward, okay, it's only touching it right here. And then, over here, the arrows do not count. So it's not touching right there, it's only touching right there, right? So arrows do not count. So there's never a point when this vertical line is touching our function more than once. So this passes the vertical line test, and therefore it is a function, okay? If we keep it going over here, once again, it does not touch more than one time. So if you want to pause this, yes, this is a function. If you want to pause this video, I'm going to go ahead and just go through and tell you the answer for each one. So why don't you try all these yourself, and then you can unpause. All right, so let's hear the answer. Once again, this one does not cross multiple times or at any one given point. So this is a function, yes. Let's go ahead down here. This one hits 2 different times, right here and right here. And actually it should happen every single spot in this function. It's touching at least twice. And so therefore this is not a function. Take note that what's happening here is we have a repeating x value, right? So let's just say this is x value 1, 2, 3, 4, 5, let's say. So this is like 5, 3, and this is like 5, 5, let's just say. So therefore this has 2 different spots, 5, 5, and 5, 3. And remember that we said that something is not a function when the x value repeats. And so this is an example of that. Here's another one, every single thing is touching at the same time. It's supposed to be a perfectly vertical line, so this is not a function. And then lastly, this one right here, each of these 3 dots, ignore the fact that this is, giving a watermark, but, this is, there you go. Each of these dots, when we move, this is not passing the vertical line test. So we can say no for this one as well. All right, so that is everything that should be able to help you go over the homework or complete the homework. And yeah, that's it.